Hi folks, today I'm going to be talking again about Comet ISON. Last time I talked about whether or not the comet has a 333-year orbit, which it most certainly does not, but today I'm going to be talking about what its orbital period actually is, if it even has one. There's been some confusion about this because if you go out into the JPL website right now and you look at the Solar System Dynamics page and you look up ISON, it no longer says hyperbolic comet, it simply says comet. If you scroll down to the orbital elements, you see that indeed the eccentricity is now less than 1. The orbital period, which you can now calculate because it is less than 1, is shown to be about 581,000 years. So what's up with that? Did the orbit change? Well, the orbit is constantly changing in the sense that the oscillating elements are not fixed in place. They constantly change with time as the gravity of the planets influence the comet. And in fact, these orbital elements are only valid for a specific point in time, which is defined right here, November 4th, 2013. Now at that point in time, the oscillating elements do show an elliptical orbit with a definable orbital period, but that doesn't mean the comet will necessarily come back around again, let alone in 581,000 years. What matters is what's going to happen in the future. How will the gravity of the planets influence the comet? And for that, you need to integrate the orbit over time out into the future and see what it's actually going to do. But you can't do that on this page specifically. It's only going to show you the elements for this point in time, which is not even after perihelion. This is pre-perihelion still. So it doesn't really tell you whether or not the comet is truly elliptical or hyperbolic. The designation up here is simply automatically generated based on what's present down here, which for most comets that have already come and gone, the latest epoch shown is generally after perihelion and gives you at least some rough idea of whether or not it was either a highly elliptical comet or possibly a hyperbolic comet. But in this case, we haven't even passed perihelion yet. These elements are still being constantly updated, and the epoch is constantly changing as well as we move forward in time. Now you may be saying to yourself, well, isn't that awfully deceptive? Why would they show us this orbital period if it's not actually 581,000 years? Well, this information is useful, particularly if you want to plug this into your own solar system orbit integrator. It needs to know where the comet is at a specific point in time, and these numbers will tell it just that. It doesn't necessarily mean it's going to take 581,000 years to go around the sun and come back again, but if you eliminated all the other planets from the solar system and just left just the sun and the comet by itself, these numbers would remain fairly static, and it would have an orbit of about 581,000 years. But that's not the case. Obviously, the planets are going to influence it over time, and so you need to integrate that over time and see what it does to the orbit. Now, JPL does have a tool that does just that, called Horizons. And if you use the Horizons Web Interface, you can request the orbital elements of ISON for any given point in time. Now, I've requested them here, starting on November 4th, 2013, and we see that it agrees with the previous page. Keep in mind that the numbers are all displayed with essentially scientific notation here, meaning 10 to the minus 1, so this is actually 0.999981. And then if you look over time, you see that very rapidly after perihelion, it returns to being greater than 1, and it remains that way over time. And that means that ultimately it's projected to be a hyperbolic comet by JPL. I know it's confusing because down here it's not, but these again are simply the oscillating elements for a specific point in time, and they change very, very rapidly. Especially this number down here, which is based upon the semi-major axis and the eccentricity. Well, these are constantly changing values over time due to the influence of the planets, and so this number changes quite a bit over time. It doesn't take a very big change. It takes a very, very small change when an orbit is this elliptical to produce a very large change in the calculated orbital period. So I'm going to show you a graphical display of this in Universe Sandbox. It's not the best solar system integrator out there for sure, but we've already seen that Horizons, which is a very, very powerful and reliable solar system integrator, does show us that it ultimately becomes a hyperbolic comet. But I'm just showing you this so that you can see how rapidly and how massively these numbers change over time. So you can see here, I plugged in the approximate orbital elements of ISON. Again, we're not going for super duper accuracy here. That's not really what this program's for anyway. We just want to see in general what kind of influence the gravity of the planets is going to have on ISON. And you'll see that it does indeed become hyperbolic. Now I should note it shows a parabolic eccentricity here, but that's really just a rounding error because the number is so close to 1. It simply displays it as 1, even though the program knows it's not. And if you look at the orbital period, you see it's almost 581,000 years. And this is going to change very quickly as soon as I hit play here, and you'll see just how quickly this number actually decreases as it gets closer to the Sun, and then very, very rapidly, right after perihelion, it becomes hyperbolic altogether. All these panels are going to become grayed out. Right now you see that the parent body is the Sun, because it's still considered to be orbiting the Sun. The orbit at this moment, with these oscillating elements, is considered to be elliptical. But it doesn't stay that way at all. As soon as it passes the Sun, it's going to become hyperbolic again. These panels will become grayed out because it's no longer orbiting the Sun. It's considered to be on its own trajectory, hyperbolic, escaping the solar system. And so you'll see that change very quickly, but I want you to pay special attention to the orbital period and notice just how meaningless, effectively, this number really is, because it is such an elliptical orbit, and because the oscillating elements are changing so quickly. This is not fixed at all, and this doesn't really mean that the comet's going to orbit the Sun every 581,000 years. So I'm going to set it here to accelerate to 1 hour per cycle, and it will very quickly go and approach and round the Sun. Again, pay close attention to the orbital period and notice how quickly it changes, and then goes grayed out as soon as it reaches hyperbolic state. So the orbital period is decreasing, decreasing, decreasing as it approaches the Sun, and then it goes around the Sun and is now hyperbolic. So now all these panels are grayed out because they are meaningless, as the comet, it has no definable orbital period. It's now hyperbolic and escaping the solar system. It's pretty much the same thing we just saw with the Horizon system, but of course the Horizon system can give you much more precise numbers on exactly what the orbital elements will be in the future, which is why I highly recommend everyone use it. It's a free tool. It's just sitting out there on JPL's website ready to use. In fact, you can access it simply by clicking Ephemeris here on the ISON page, and it will automatically load that up as your target body, and then you just specify what you want. Default, I believe, is observer table, but if you want the orbital elements, you just change that to orbital elements and define your date. And there you go. And you'll see for yourself that ISON's ultimate fate is still projected to be hyperbolic according to JPL. Hope you have a nice day.